So yesterday, the section 1, we study about the limit of each of the small rectangles when we approximate a curve. And section 5.2, we have a proper definition of an integration, right? Where the integral sign is like this, and the upper bound, upper limit and lower limit is a and b. So follow this definition. So from now on, we can write the integration following this definition here in terms of limit, okay? Where xi star are the sample points on that intervals, okay? It is called the Riemann sum of this. And here, integral of a curve, sometimes the graph is negative and sometimes it's negative. So the integral of this will give us the net area of the curve, right, on that intervals. Very good. And the theorem for any point for a given intervals, we discretize the domain into n rectangles. And for any xi's in that intervals, we can determine using this formula where delta x is b minus 8 over n. So we can compute all these information. And these are the formulas we need to remember in the notes. So this is the sigma notation. It's very important. That the sigma of a sum will be the sum of the sigma here. Okay? And similarly, the difference. Or any terms here inside the sigma sign, if there is a c, a common factor, we can take it out of the sigma sign here. Okay, and this is an example. So in this question B, we're trying to use the definition to compute this integration, okay? Where delta x is given, and we can compute it. It is 3 over n. Xi's will be the lower bound plus I times delta x. In this case, it is I times 3 over n. Right? From the definition, we know that the integral from 0 to 3 of this function would be the limit for n approaches infinity of the sigma sum from I is equal to 1 up to n of the function f at the points xi and delta x here, right? Now, we know the function, this guy, right? Therefore, we can, and we know xi is here, is given in this formula. So can we rewrite the limit here? Limit from n approaches infinity, right? The sigma sign, we just rewrite it here. When I is equal to 1 to n. And here in this case, what is f of xi? First, we'll replace xi by the explicit formula here, right? Is that okay? Then what is it here? Yes, I times 3 over n. That is xi, right? And delta x here, what is it? Yes, 3 over n. Thank you, Daniel. Very good. So is it clear for everyone? Now we are given the function f already. So can you tell me what the value of f of this guy? The function is x cubed minus 6x. And what is it here? What is the value of f of I times 3 over n? This guy play a role of x, right? Here. Thank you, Morgan. So are we good with this? Do you all see it? Is there any question here? Very good, right? Now, let us make it clear. Limit when n go to infinity of the sigma from I is equal to 1 to n here. This is the power rules, right? Power of a product. So it means, what is it here? The denominator is n, right? The numerator raised to this power, and the denominator will also be raised by this power. So what is it here? Which number should I write here? Yes. And here? Perfect. Right. And minus 6 times this guy is it equal to 6 times 3, which is 18 times I over n. Is it okay? And the number 3 over n, we just rewrite it here. So are we all good with this? Yeah, right? So look at the notes I gave you in the section 5.2. Okay. So this guy, you can write either, if we use equidistant, then this could be this, then multiply with delta x, right? Or it is the sum of fxi if they are all equal. Each of them, it could be both. Either way is fine, okay? Now, again, this is the difference of two things, then multiply with 3 over n. So can we distribute this guy here? We can file it normally, right? So what do we have if we do so? And what do we have in the first terms here? Very good, 3 over 4. And multiply, divided by, very good, minus, this is 18, right? 18 times 3, right? 36 I over n squared, right? Oh, wait, not 36, I'm sorry. 54, right? 8 times 3 will be 24, yes. So now, which formula should we use here? Now look at the notes I gave you. In the sigma notation formula from number 5 to number 11, which formula should we use? Number 10, right? Very good. So do you all see it in the notes? Very good. So the sigma of a difference, so number 11, yeah, will be the difference of the two sigma here when I is equal to 1 to n of I cubed multiplied 3 to the 4 divided by n to the 4th here minus sigma when I is equal to 1 to n of this number multiplied I divided by n squared, right? So are we good with this? Right? Then here is the limit of a difference here. So which formula can we use here? Eleven we have already used already. 7, yeah, 7. Let us look at this. This guy. The sum from I is equal to 1 to n, right? Of all these. Huh. Interesting. I think we can write it in a better way. In order to apply the formula number 7 here, I think it should be better if we yeah, it's fine. So we should be very careful. Here I is a running numbers, right? And n here is a fixed number. Do you all see it? Here, 3 to the 4th is also a fixed number. Okay? So we can treat them as a constant. Do you agree? Then, if it is a constant, then can we use the formula 9? Right? Do you all see it? Because n is a fixed number, right? Therefore, if we can do this, then we can write 3 to the 4th divided by n to the 4th, multiply with the sum from I is equal to 1 to n of I cube. Minus, similar story, 54 is a number. N is a fixed number in this case, and n squared should be a constant with respect to the sigma sign here. So we can take them out of the sigma sign here. Is it clear? So we should be very careful. If you don't see it, please ask me and make sure that everything is fine. So how is it? Are we good? Then, again, this guy, which formula should we use? Perfect, number 7, right? So the sigma from I is equal to 1 up to n of I cube. This is a constant, the number, we can write it here. And this formula gives us n times n plus 1 divided by 2, and then raised to the power of 3 here. Okay. Oh, square, thank you. Thank you, Michael. Good catch. Yeah. And the second guy here, sigma from I is equal to 1 up to n. What is it? Perfect. So, is it good? Good job. Now, let us play with this a little bit. 3 to the 4th, we just rewrite it. N to the 4th here. And the power rules for this fraction, what do we have? Very good. And? Perfect. Very good. Thank you, Morgan. And here, the number, can we write it? Can we cancel it out? Right. 54 divided by 2 give us 27, right? It will be 27 times n and n plus 1 divided by what? Yes, n squared. Good job. Catherine asked, why isn't it cube? Which one, Catherine?
Whenever you had I cubed in the first part of it,
Okay.
I didn't know why it was squared instead.
Yeah, there's a formula in the notes, section 5.2. The sum from I is equal to 1 up to n of I cube. From that formula, you see it will be n times n plus 1 divided by 2 squared. You can find some reference proving this, but we do not do it in class here today. Okay?
Okay, thank you.
Now, just accept that, and then we continue. Okay? Okay. So, in the numerator here, what is the highest degree of n? Square and then square. The highest degree would be n to the fourth. The highest degree of the denominator is also 4, right? So if we rearrange the number, can see it better. So 3 over 4, these are number. We write it here. Okay? And the numerator here, it is n squared times n plus 1 square here. N to the fourth, we can write it n to the fourth of n squared, n squared here. 27 times, if we write it n and n plus 1 divided by n, the n squared we separate it into n times n. So I just rewrite this number in different way. Okay? Do you all agree with this? We did nothing, just rearrange the power rule. Okay, now we play it with this. Limit from n go to infinity. The numbers here, we just rewrite it. These are all the product of things, right? Let us write it this way. N squared divided by n squared, multiply with n plus 1, and n squared, we write it this way. N divided by n, and n plus 1 divided by n. So, do you agree? Just use product rule, power rules. Okay. So, when n goes to infinity, the limit of this, okay, n squared divided by n squared give us 1, right? So this number, it will be 3 to the fourth will be 3 squared times 3 squared, which is 9 times 9, and it will be 81 divided by 4. N squared divided by n squared give us 1. And here, this guy, if we break it down into a sum, it will be 1 plus, what is it here? 1 over n. N plus 1 divided by n. It will be 1 plus 1 over n. Okay, and then square. Minus 27, n divided by n give us 1. The similar story, what is it here? 1 plus 1 over n, right? Very good. Then the limit, when n go to infinity, right? 1 over n would be 0. This would be 0. Okay? So the limit of this guy, it will approaches to 81 over 4 times 1 here, minus 27 times 1 times 1. So finally, we got this result. Okay. Are we good? Right. Then very well. This is a whole number and a fraction, so we can make multiplied by 4 divided by 4. Now they have the same denominator. So it would be 81 minus 27 times 4. And finally, it would be negative 27 divided by 4. So from definition, we have already computed the integral of this function, right? Is it clear? Okay. Are we good? So we can use this definition to compute any other function. But later on, you will know how to do it faster without using the definition. But for now, we know the idea, right? How to do it. So we continue. In the next part, we have the midpoint rule, where we approximate the integration by the value in the by the midpoints. That is the average of the left and the right value. Okay. It's similar. Then let us consider this example. The same story. Let us use the midpoint rule to compute with n is equal to 5. To approximate the integral from 1 to 2 of 1 over x dx. So okay, 5 points. Then this is 1, this is 2, and we know that this is x0, right? And delta x is b minus a divided by n. In this case, it will be 2 minus 1 divided by 5, which gives us, what is it here? One over 5, right? Okay. Two is right here. So delta x here is 1.2, 1.4, 1.6, 1.8. Okay, then two is right here. And the midpoint will be here, right? Okay. So this guy is 1.1, the midpoint, 1.3, 1.5, 1.7, 1.9. We know all the information here, right? So from the definition, approximation, integral from 1 to 2 of 1 over x dx, it will be delta x, right? Let me just write it down clearly. Integral from I is equal to 1 to n of f of xi dx. This is sample point xi star, right? So it will be the midpoint f of 1.1 multiply with delta x here, right? Plus, or they all multiply with delta x, so we can factor delta x out. And what is it here? Yes, and what is it here? Yes, and perfect. Thank you, Morgan. So, and all of them multiply with the same things, delta x, right? Okay. So what do we have here? F of 1.1, what is it, Gary? Can you help me? F of 1.1. Perfect. N plus. Perfect. And 1 over 1.5 plus 1 over 1.7 plus 1 over 1.9, right? All multiply with 0.2. So finally, when you do this computation, it will give you the number 0.691908 using the midpoint rule, okay? So when you go home, you can play with the left end points formula and the right end points formula. You will see how it looks like compared to this, okay? Now the idea is clear, right? So, and you will see that these are some properties of integration. If you flip the boundary, the endpoints from interval from A to B, so integral from B to A of fx will be the negative of the integral from A to B. So just remember when you flip the endpoints of the integration, change the sign, okay? And the similar story, the integral of a constant, it will be that constant multiplied with the difference of the interval, B minus A, okay? For example, what is integral from 1 to 10 of 2 dx? Yeah, 2 times 10 minus 1, right? Yeah, 18. Perfect. And similarly, integral of a sum will be the sum of integral. And the constant here, constant c, you can take it out of the integration. Okay? Out of the integral. And the integral of a difference will be the difference of integral. And similarly, integral from a to c, where c is the midpoint of a and b, imagine this way. There's a number c in between. So integral from a to c plus integral from c to b, it would be the integral from a to b, right? Makes sense. Okay. And yeah, similarly, we have the comparison. If the integrand fx here is positive and x is any numbers between a and b, the variables between these intervals, then the integral of this positive function, it will be also positive. Makes sense, right? Because integral is a sum. Sum of all positive things will give us a positive numbers. Makes sense, right? If the function f of x is larger than the g of x for any point x between a and b, then the integral of f will be larger than the integral of g. It makes sense. You can draw a graph and you see, right? If this is f, this is g, makes sense. The difference of f and g, integral from a to b, will give us this area. Okay, very good. And if f is between a minimum value m and smaller than the maximum capital M here, then we have the inequality here, right? Makes sense. You can imagine that we take the integral all over this, right? Integral of a number m here from a to b give us m times b minus a, right? And integral of a constant capital M over a and b give us capital M times a and b. Makes sense. And the integral of function f will be this guy. Okay. So these are all the properties we need to know. Okay. Now let us practice some example. Here, look at this guy. Let us compute the integral from 0 to 1 of number 4 plus 3x squared dx here. So, what can we do? You can look at the notes and tell me which formula we should use to compute it. First, this is a sum, right? So can we write it? Integral from 0 to 1 of 4 dx plus, what is it here? Perfect. Very good. And here, integral from 0 to 1 of the number 4 give us? Yes, 4 times the difference here. And here, 3 is a constant, right? 3 is a constant. Can we take it out of the integral side? It will be integral from 0 to 1 of x squared dx. Okay? And we have done this formula before. integral from 0 to 1 of x squared, you can write the definition of this in limit forms and apply the formula. And we'll see this guy is 1 over 3. Therefore, in the end, it will be 4 times 1 plus 3 times 1 over 3 here, right? It will be 4 plus 1 and 5. Okay? This is an example of using these properties. Is it clear? Okay, let us do another example. Integral from 0 to 10 of f of x is dx is given as 17, and integral from 0 to 8 of f of x dx is 12. We need to find integral from 8 to 10 of f of x dx. So look at the notes. Which relation should we use here? Yes, difference of intervals. So, i.e., integral from 0 to 10 of f of x dx, we separate it into two integrals, right? It's from 0 to 8 and integral from 8 to 10, okay? Then integral from 0 to 10, we are given that it is 17, right? And from 0 to 8, we are given that it would be 12. Okay? From this, can we tell if integral from 8 to 10? What is it? Yeah. 17 minus 12, which is 5. Very good. So is it clear? So tomorrow we will continue the section 5.3. And yeah, that's it. You have a good one and be careful going outside this day. See you, everybody.